to share with us his latest insight. Here I will briefly introduce Xun Yan to all of you, as he is new to us, okay? But he's not new to our field. Xun Yan is a professor of linguistics, second language acquisition, and teacher education and educational psychology at the University of Illinois at Urbana-Champaign, UIUC. He is a faculty member in the Beckman Institute for Advanced Science and Technology. He received his PhD degree in second language studies from Purdue University and is a language tester by training. And UIUC, Xun is the director of the undergraduate program in linguistics and TESOL, and the supervisor of the English placement test and the oral English assessment interview. Xun's research interests including speaking and writing assessment, psycholinguistics and computational approach to language testing, and language assessment literacy. His work has been extensively published in journals such as Applied Linguistics, Assessor Writing, Foreign Language Annals, International Journal of Bilingualism, Journal of Second Language Writing, Language Assessment Quarterly, Language Learning, Language Testing, System, Studies in Second Language Acquisition, and TESOL Quarterly. A lot. He was the recipient of multiple important awards at different stages of his career. Actually, he received awards at all ages, key stages of his career, as a young budding scholar and then as a mid-career scholar. Xun is currently the co-editor of Language Testing, which is a flagship #1 journal in language testing and assessment. Okay, here's something he has never heard about. I first met Xun in 2015 at the ALA conference in Bali, Indonesia. I attended his talk and was impressed by his solid scholarship. At that time, he was actually very young and just finished his PhD not long ago, right? Because of his excellent speaking and presentation skills, I actually mistook him for an ABC, which is American-born Chinese. When I learned that Xun was actually born and raised in mainland China and only went to the US later after his first degree, he went there for master and PhD degrees. I felt very proud of him. And I could immediately see that he has a bright future as a rising star in our field. Over the past 10 years, I have met Xun at various international and regional and national conferences, and I have seen my foresights gradually come true. Xun steadily publishes his research every year, and many of his research are quite important for the field. And he has grown into a prominent figure in our field, language testing and assessment. Unsurprisingly, for me, Xun became the co-editor of language testing last year, right? Last year? 2 years ago, okay. Language testing being the flagship journal of our field, I believe through this role as a co-editor, I can see that Xun will influence the future direction of our field in the years to come. With much pleasure, let's invite Xun to share with us his insight on the future of writing assessment in the age of AI. Please join me.
Thank you so much, Professor Xie, for the very, very kind introduction. I didn't expect the second part of it, but it's a great honor and privilege to be here. It's my very first time visiting the beautiful campus of the University of Macau, and thanks to Faculty of Education for this invitation, and thanks to Professor Xie in particular. So today, I'm going to pack a lot of information within probably an hour. We'll see how far we go, but what I really want to share about is what we've been doing in the past 10 years. So as Professor Xie mentioned, I started working in 2015. So the term AI, even though it's a buzzword right now, but we started back in 2015. So I'll try to see how much I can share today. But I'll try to combine also how I think of this topic from a broader perspective and also demonstrating to you the kind of AI explorations we've done in our local context. And a lot of my work has focused on speaking and writing assessment, and in fact, a lot of it is actually focused on writing assessment. It's a very big topic in American universities, as you see. So I'm just gonna jump right in. So the talk has kind of 5 parts. I'll first very quickly go through the technological innovations in language or writing assessment. Moving on to talk a bit about different kinds of assessment, where I differentiate large-scale classroom-based and local writing assessment. Then I will talk about the application of AI from the perspective of sustainability, right? Trying to give a kind of a critical lens to what we're doing right now with AI. And then I'll demonstrate to you what kind of sustainable AI solutions we need to explore in our local context, and hopefully use that as springboard for discussion and conversations. And I'll also, in the end, conclude and talk about what I think as future directions for writing assessment in relation to AI. All right, so to begin with, I want to put a little bit of positionality statement so that you can understand where I'm coming from and why I'm actually interested in what I'm interested in. So I'm a language tester by training, as Professor Xie mentioned. I'm not a computational linguist, I'm not a machine learning engineer, but starting from 2015, I decided that I want to get into the computational world. And I started with data, with machine learning. That's because I have a very long training in applied statistics and a pretty good sense of what data is and how to deal with data. And my personal interest has a lot to do with analyzing linguistic features, whether it's writing or speaking. So handling raw data has always been something that is very close to what I do. I didn't feel like jumping into machine learning and dealing with computation, but with NLP or speech signal processing is something too different from what I do, right? So maybe that's kind of where I'm at. Even though generative AI has become such a buzzword, my involvement with AI has not so much been related to generative AI, even though our team is exploring that. But that might also carry some bias in terms of how I see AI, how I think of generative AI, as you will see later on. So given all of my personal interest, I've also been quite involved in developing local assessment. So I was involved in developing 4 operational language tests in American universities. And then currently I'm managing 3 local testing programs. So you can see a lot of what I do not only focus on R&D, but also focus on day-to-day management and operation of a testing program. And very recently, I was also selected by my university to receive entrepreneurship leadership training. So a lot of my ideas or assumptions about AI has also changed a little bit, mostly from the feasibility and sustainability perspective. So it has a combination of linguistic, computational, data, and also sort of business socioeconomic perspectives to all of this together. Right? So that's kind of who I am. Maybe you will see my own biases as I present to you what I think AI should be in writing assessment. So in terms of technology and language testing assessment, I think it's not an overstatement that language testing as a field has always been driven by technological innovations. And AI, if we put AI in this bigger sort of picture, it's only one of the recent events that started to generate a lot of interest, but has never changed the trend of technological innovation and improvement over time. So in particular, related to writing assessment, we can see that starting from using a computer to deliver a test, all the way to automated essay scoring, and now using generative AI to develop test items. Right? A lot of these are very influential because of technology, which has enabled us to do a lot of things that we haven't done before. And because of all of these innovations, oftentimes when we're running a local testing program, we are always faced with the challenge because we don't know exactly what to do. Especially right now with the explosion of technologies, what do we choose to invest our time and effort, right? Is it automated scoring? Is it automated test development? Or is it something else, right? Like remote proctoring. all of these AI-based applications. So what do? How should AI technology innovations be looking like in different assessment contexts? Right? So to understand this, we must understand the affordances as well as the affordability of AI solutions. Right? So that's why I want to start by differentiating three kinds of assessment. On both sides of this, you probably are very familiar. One is large-scale tests, right? Usually these are international tests that are given to a very broad audience or test takers. And on the other extreme, we have classroom-based assessment, focusing on teacher-student interaction or student-student interaction in the classroom. But by and large, the majority of language testers actually live in this intermediary space, which is what we call local tests. So these are tests that are actually standardized tests. They are operating or being run on a regular basis, but they're just not as big as large-scale tests. So it really differs from classroom-based assessment because you still need to fulfill all the requirements in terms of validation, test development practices, and other kinds of test uses. But at the same time, oftentimes the resources are quite limited. To give you a bit sort of a clearer example, right? This is actually what we can see in a lot of American universities where, for admissions purposes, a lot of the students will actually use TOEFL or IELTS, right? These big, large-scale tests as their admissions method. And oftentimes, the university will actually make an initial cut and say, well, maybe at Illinois, we used to cut at 80 or 90. We don't have a cutoff right now, but you can kind of imagine, right? Everybody who gets into the university will score about 90 on TOEFL. And then if they score really high, let's say beyond 115 out of a 120-point scale, we consider them as very proficient, right? But anybody who's within this middle range are considered potential students who might benefit from additional language support, especially writing courses. So for local tests, let's say if you want to develop a writing placement test, our task is to think about ways to maximize the potential for a test to generate useful information for this narrow range of proficiency. So it's actually quite challenging to do. But within this range, oftentimes you need to do a lot of things, right? You might use it for placement, and if students are actually in the class, you might want to use it for diagnosis and achievement. And sometimes if students need to take a proficiency test to get some kind of employment certification, then you have to fulfill the certification needs, right? So within all of this, it needs to be served within one local test, right? So it's very clear we're dealing with limited range of proficiency, and we need to serve a lot of purposes. And it's a big contrast to large-scale tests, because oftentimes large-scale tests has only one purpose, and they have a lot of resources to begin with. Now, after local tests is actually being administered, that's when we start to funnel students into the classroom. And that's when classroom-based assessments start to occur, right? So we should see this sort of three-tiered assessment context that are connected within a local institutional context. Now, so one thing I forgot to mention is that as the tests become more and more specific and more focused, we start to lose the scale of the test, meaning we start to test fewer people, we started testing a narrower range of proficiency, and at the same time, if these local tests can be made to work, they can generate more instructional values than large-scale tests. Right? So that's why we start to face this tension where we always jokingly say people who work in the local context are being asked to do a lot without a lot of resources to begin with. So we're actually working on magic for some of this. So here are just some of the challenges I mentioned. Restricted range of proficiency, one test, multiple purposes, and oftentimes in local context, online big tests, we don't really generate any revenue. So then you have to think about your budget and your resources. How can you make sure that can work within the institutional policy context? And oftentimes local tests have a much more complex stakeholder network. You deal with policymakers, administrators a lot more frequently than if you are working for a large-scale test. Personnel resources, right? Not only the resources are limited, but oftentimes you need to actually employ students in your context. So you can't always hire full-time employees, right? So in this process, because you're hiring students, you also have to think about their own professional development. So there's research and mentorship. All of these needs to be factored in when you're actually running a local testing program. So when we actually look into AI, right, we know that there are these contextual variations. So what can AI, how can we actually use AI across these contexts? So we've looked into all the published literature until the end of 2023. So in the last few years, there can be a lot more literature. But what we saw was that if we are looking at just the contextual variations by looking at large-scale, local, and classroom-based assessment, we can see most of the AI applications focus on classroom context. And when we look at the major components of test development and use, we'll see whether we're dealing with creating, developing new constructs or new criteria for assessment, or test development, scoring feedback, and perception and use. We also see that, interestingly, most of the study are either about scoring feedback, or more specifically, just ask people about how they think of AI. So it's perception and use. Very little is focused on R&D, right? They're not so much about developing in-house AI systems. And interestingly, you see there's not much published about large-scale tests either. But when you look into that, you will see that a lot of the AI systems are mostly proprietary. They're developed to make profits. So when companies develop them, they will never publish them because they don't want to reveal their secret sauce. So the picture that we got just from publication can't really reasonably represent what AI, how AI looks like in a large-scale context. Right? But I think the picture between classroom-based and local tests is quite telling. So you can see in the local context, it's basically empty. There's not much happening with AI. All right, so we can zoom in a little bit. When we look at AI in large-scale writing assessment, even though we don't have a lot of literature, but we can actually look into the website of testing companies and see what is actually being done. We can see there are a lot of interesting developments. Right? There's definitely a lot of conversations about how AI can be used to innovate test constructs. Right? We start to have a lot of work looking at how we can test integrated skills, how we can test interaction, and multimodal performances. Right? These are certainly directions that I think our field is heading toward in the next maybe 10, 20 years. But there's also, in terms of development, there's a lot of automated item generation. For test administration, because of COVID and AI, a lot of the companies are now moving to online mode. So with AI, it needs to come with remote proctoring. So these are basically computer vision. So it's a little bit further away from with language, yes. But that's also a vibrating area that's developing very fast. But test scoring, I think, is still by and large the biggest component, where a lot of the effort is focusing on extracting more product and process features of test performances, and then feed it to automated scoring systems. So that's for large-scale tests. In contrast to that, when we look at classroom-based writing assessment, the picture is a lot more straightforward. Right? There's some discussion about automated item generation, but it's very limited. Most of the discussion focuses on evaluation and instruction. Right? It's about how we can use not AI system anymore, it's actually generative AI tools to score essays and to produce corrected feedback. And also, how can we actually use generative AI tools together with dynamic or diagnostic assessment so that we can connect assessment with teaching and learning. Right? So this is the clear contrast between large-scale and classroom-based. Then, in the local context, like I said, there's nothing happening. I didn't really find any literature that is actually documenting whether it's the use of AI tools or the development of AI tools in local testing programs. So, from these bigger picture differences, what we can see, there's some kind of alignment, right? Clearly, AI technologies is actually reducing the gap in technology-enhanced assessment practice between large-scale tests and classroom-based assessment. And in fact, this was my biggest fear, because if you're actually involved in assessment programs or the field of language testing and assessment, you would know that when there's monopoly or proprietary information with AI and large-scale companies, that information tends not to be carried through to classroom-based or local context. So if we maintain that trend without anything happening in the local context or classroom context, chances are the gap between large-scale tests and local tests will become bigger and bigger. Right? But it's good that we're not seeing that yet. And yet, we still see a general development versus application divide between these two contexts, where in the classroom context, oftentimes scholars or practitioners are relying on freely available off-the-shelf tools, and they tend to conduct studies that are a one-off experiment without clear or scalable or sustainable implications for testing operations. And oftentimes these are used in low-stakes formative assessment context. And even though there are some implications about testing and assessment, they tend not to be made by scholars who have experience running testing environments. So you always feel there's a bit of a disconnect between what the implications are, how we can actually use it in the real context. So just to give a quick example of automated scoring, because this is sort of the connecting dot between the large-scale test and the classroom-based assessment. So we know that automated scoring has come a long way, right? From the very beginning, the page sort of seminal paper that everybody cites now, we're talking about using surface-level features like sentence length, trying to feed into a regression model and trying to see how well that predicts test scores. And that's the very initial structure of an automated scoring system. And moving on to the 1900s and 2000s, and you will see that a lot of these are coming from testing companies like E-Rater, where they start actually spend a lot of effort on feature engineering, looking at a lot more construct relevant features that can be fed into machine learning models. Now, in the early 2010s, we started to see development in the realm of machine learning, where the features remain the same, but the statistical modeling process behind it become more and more sophisticated. Right? This process has led to a lot more, sort of much more improved prediction performance, and also allowing engineers to use more discourse level features because of that collaboration between content experts and engineers. But it's not until more recently we start to see development in deep learning models and generative AI. That's when automated scoring has really become widely available to almost everyone. So you can see that when we're actually dealing with classroom-based versus large-scale tests, a lot of the earlier approaches are actually focusing a lot more on development, whereas the more recent development focus on use and application. Right? So that's, I think, where the divide is, because a lot of the groundwork in terms of development has been carried out by early research, and then the more current research focuses more on customizable tools that can be tailored to different uses. All right, so over time, we can definitely see machine learning models are becoming more and more sophisticated, and it's more reliable. The state of the art is actually telling us machines are more reliable than humans in almost all studies right now that are being published. And it's very powerful at capturing complex linguistic and rhetorical patterns and features. And it's better at predicting than traditional feature-based machine learning models. And it can actually generate more detailed information that can be used for diagnosis and feedback, especially in low-stake contexts. But as we saw, when we move to sort of the deep learning models, the problem is we're becoming more like a black box, right? So because of the machine learning model, it's hard to figure out what the machine is actually doing, right? So there are a lot of concerns because A, in terms of feasibility, right now, to develop a deep learning model, you have to rely on lots of training data. And this is oftentimes not available in even smaller testing companies. Only those big players can actually do it. And in terms of score interpretation and accountability, this is actually where the most of the challenges are, because as highly profitable, high-stakes testing companies, oftentimes they do face lawsuits about score interpretations or challenges. So for them, just jumping right into a black box approach is actually working against them. So in large-scale testing companies, actually what you see is a very initial exploration of deep learning models, but then quickly moving back to feature-based models. So if you look into any of the major testing companies, I doubt any company is actually using deep learning models. It's very different from generative AI, like ChatGPT, for example. Also because more and more companies start actually training their own data because that they know that they need to start to control for test bias. If they're just using, let's say, GPT, chances are they have no control over the actual data that they use for training. Right? So that's a big difference. But when you look at the classroom context, the questions, the interests are quite different because when you think about the use of generative AI for automated scoring in a classroom context, we're mostly thinking about a very practical problem. That is, how can we actually use AI to reduce teachers' workload, right? And research seems to suggest that it's actually happening. It's really helping teachers to, better allocate their time for something else, or focus on higher level tasks. And the performance seems to be adequate, whether it's scoring or feedback that students are actually getting. It's all telling us that there's a potential for students to interact with AI and to actually lead to learning at some point. And both teachers and students seem to feel similarly about the constructive nature of generative AI. Right? So it's quite different. So why that is actually happening, I think to understand that a lot of people will think that that's because of the technological difference, because in companies you have all the resources, in the classroom context we don't. Well, yes, that's part of the reason. But actually, if you fit all of this in from a business perspective, actually, you probably will understand why the companies are actually doing what they're doing better. So when you think about any kind of enterprise, right, we can have for-profit and non-profit organizations, right? For most for-profit organizations, I think we can understand their business performance or business operations from 4 interconnected elements. One is called assets. This is basically what kind of resources the company is able to produce or provide. Value proposition is mostly about sort of how you can actually create your revenue. What's your tool to create value? This could be realized either by generating profit or actually lowering the cost so that you can actually get more profit. Realization of value is mostly how you actually generate revenue, right? So these two things are definitely closely connected. And scope of enterprise is basically what resources and personnel that you have in your supply network that can actually help you maintain the sustainability of the system. So to understand this, then looking back at AI solutions in large-scale testing companies, you will clearly see there's actually a very, very clear alignment across what they're actually trying to do. So we know there are all kinds of AI solutions, right? Automated item development, automated scoring, AI-based proctoring, right? All of these are in some ways trying to create a couple of things. So first of all, we think about these assets, right, as what they can actually produce. So by doing this, whether it's technical bit of things or actually UX and UI design, is actually leading to a couple of realization of value. So first of all, by doing this, they can scale up their test administration. Because when everything is scored by AI or produced by AI, they don't have to spend any cost on test centers. And they can reach more test takers around the world. So it increases their market share. At the same time, because even though AI might take a lot of initial investment, but when they're actually operating, it's basically variable cost. So you lose that human cost associated with test development and operation. So by doing this, you make your test much cheaper. It's more affordable by test taker. But at the same time, because it's more accessible, you can scale up your test operation. So your revenue is actually going up by making the test cheaper. And to do this is not easy because developing all of this requires a cross-functional team, lots of data and expertise, right? You need language testers, you need language specialists, but you also need software developers, and you also need UI UX designers, and you also need AI engineers or machine learning engineers. But all of this are communicating very coherently that can lead to a sustainable and growing business model. Right? So that's why testing companies are willing to invest. And that's why they can actually create multiple systems that can connect together. And because with AI systems, there are all sorts of issues as well, right? Whether it's reliability, validity, fairness, ethics, right? And here I won't elaborate, but I think these are topics that we're very familiar with. But what's really making all these AI systems work is not just the development itself. It's a quality control system that allow them to connect all of these together. So the important thing for these AI companies is not just about making things deliver. It's about knowing when these problems fail, how can they fix them. So you always need a team like this. So a lot of the investment for these AI-based testing companies are actually on personnel, not so much on the materials. It's a very different business model than, for example, well, if you're comparing Duolingo, for example, with BTS. That's what we're seeing. With Duolingo, most of the investment is on personnel. And with BTS, most of the investment is actually on the skills. So it's quite different. Now, switching gears, if we try to actually work out this problem in the local context, it's quite messy. Because this is something that I was trying to work out, is like, what kind of value are we actually generating? What's our value propositions? I don't know, maybe creating AI-based system can give better language support that can make our students more academically successful, making them more employable, right? But these are not directly profitable as what we saw in large-scale testing companies. And maybe we can use AI to create audience scoring feedback, but test development and remote proctoring, these are a lot more challenging to do in a local context, right? So when you're trying to, the font got screwed up a little bit. When you're trying to think about what kind of value you're actually creating, maybe reduce workload, mostly I think is a niche research topic for our professors and students. And maybe there's some tailored assessment instruction, right? But these are not as clearly coherent as what you see in the large-scale testing company. And more importantly, where does the expertise come from? Where's the data? Where's the personnel? Right? These are all big challenges if we want to focus on R&D with AI in local context. So I don't think we can easily get a sustainable business model for local context. So the challenge becomes, we need to be really selective, right? And when we try to select, we need to first think about, because we don't have revenue, we need to think about where does our funding sources come from. In the US, most of the local testing programs have these funding resources, right? So these are mostly, provost office funding, mostly coming from international student fees, college funds that are used to pay instruction, and maybe there's some discretionary departmental funds to cover students. Maybe if you're lucky, there might be additional R&D funding, right? Otherwise, you have to look for external funding sources. I'd say most of the time in local context, the funding comes from the first two. This is the instructor budget, right? So there's not a lot of room for you to think about. If you want to invest in AI development, R&D, you really need to think about where you're going to cut in terms of your cost, right? Because you're not getting more funding. So this is the conundrum that we typically face, is that there's a lot of things we want to explore in the local context, or maybe in the classroom context, but we really don't have the kind of funding to do so. And instead, that's why we're starting to see more people using freely available software, like generative AI to achieve those purposes. But the irony is this. When we think about assessment in local context, we often say that local tests or local assessment are better because it's more sensitive to the local needs, right? As language teachers, we oftentimes know our students, we can develop assessment that can feed into their assessment needs. But when it comes to generative AI, what we start to see is the opposite. That is, large-scale testing companies start to have tailor-made AI systems. And in local context, we're relying on commercial tools. And we don't know whether or not the cost is going to increase anytime in the future. So we're quite vulnerable in this context. So given all of this, right, you have to question where's that flexibility and sensitivity that is associated with assessment in local context. Right? That's the question, right? To address this, what I think that needs to happen is sustainable AI solutions. That is, we can't be as ambitious as testing companies look for all these AI solutions. But at the same time, we can't be as just content with using commercial tools. There needs to be some R&D, but we need to be really careful in selecting and making decisions about where to invest and how to invest. So when thinking about choices, I think it's really important to think about the actual nature and purpose of the writing assessment, right? In any local context, I'm sure the purpose will be slightly different. You really need to think about what is the value when we're using technological solutions to address this writing assessment. And always think about technology as enhancing assessment rather than driving assessment, right? And then focusing on sustainability as you navigate through a lot of the problems that we face in the local context: ethics, fairness, transparency, and responsibilities. So you do need to ask a lot of questions, right, when you're looking at different contexts. The first is, what are some of the core assessment problems we're trying to address? Is it for placement? Is it for diagnosis? or is for something else, right? What kind of value can AI create for primary and secondary players, right? If, let's say, the policymakers in your context really want you to just focus on placement, and if you dedicate a lot of effort on diagnosis, it's not going to work. Right? Eventually, you're going to face competing priorities, and you have your AI solution might fail. So you need to create that synergy. And then what resource and expertise can be used to support development and quality control of AI innovations, right? And what's the model of funding? If funding is not available, what's the model of collaboration? Mentorship, right? Can you actually creatively look for resources in your local context by working with others, right? And these are things we need to think about, and how can this system be maintained over time? So once you figure out these questions, you will be able to work on your own worksheets, because to have AI-based writing assessment, you need a lot of expertise. You need definitely, well, alpha writing, language assessment, right? These are the core value that we still hold to our heart. But at the same time, software development, UI, UX, computational linguistics, and psychometrics, these all need to play all together, right? You need to build a community of practice to make sure everything works together, right? And then by doing so, you need to think about their interests, right? To put it very bluntly, why would computer scientists want to work with you in this content? Right? What kind of value are you creating for them to make this collaboration model more sustainable? So I think, even though, given all of these considerations, there's two solutions. It's just within each context, things might look a little bit different, right? So I want to dedicate some time just to showcase the kind of AI solution or exploration we've done in the local context. Hopefully we can give you an idea of why we do this to begin with. How do we actually go for different collaboration models and company models to build our AI systems? Right? So to give you an idea, probably a lot of you are very familiar. If you're familiar with the higher educational context in the US, you know that international student population is a very important source of revenue for US universities. And they also represent a very big effort for us in terms of writing support and writing instruction, and writing assessment as well. And in fact, in our context, even though there are a lot of policy changes in the last couple of years, our international student population has been increasing every single year. So this stats only goes to 2017, but right now the number has gone up a lot. So we've only saw a dip during COVID, but now we're actually back up in record number again. So when we're dealing with international students, we're basically talking about 2,000 students every year coming into our university that need to take our test. So it's a big test. And our test needs to serve the first year writing program. And in our writing program, there's some interesting tension. Is that there's a tension between whether to focus on rhetorical structures or to focus on lexical grammar issues. This might be a common issue in the US in general. So this has led to a lot of debates about where does the curriculum focus should be and what to do in instruction. How do instructors deal with students? And language teachers don't want to develop diagnostic assessment for their students. They want to rely on the testing program completely, and they also don't want to spend time grading. So you can see a lot of the burden actually falls on our team. And our team only has, back then when I started, it was just me and one RA. Now I have myself, 3 coordinators full-time, and then 20 RAs at the same time. So it's a growth over time, but it's still a very small team when you compare that with an instructional program. So our placement structure is very simple. We test both graduate and undergraduate students, and there are 3 levels of placement. If you're placed into the lowest level, you take 2 semester writing courses. If you're sort of placed into the middle level, you take 1 semester. If you're high enough, you can be waived of taking ESL writing courses. And the structure applies to both graduate and undergraduate students. For the undergraduate students, it's slightly different. They can be exempt from ESL, but the students take mainstream writing courses. That's the main difference. Our test has also gone through many iterations, which I'll get to in a little bit. But right now, this is actually where we are. It's a integrated read, listen to write essay task. The whole task is about 90 minutes long. It's testing argumentative writing. these are the exemption criteria, right? So you saw students who actually need to take the test are falling into sort of this middle category. Over the years, we've done a lot of changes. So the test started in 2002, much longer before I started. Back then, you know, it was just like, everything was paper pencil. It was a single essay, but it's a process-based writing. Students actually come in the morning, they write a draft, they need to find a friend, a real person. They need to get along for a whole day and come back in the evening and rewrite. And they need to give each other feedback. So it's a very kind of day-long, authentic process. But over time, we know that it's not going to be sustainable because our international students has increased dramatically over time, and we need to test them online before they come to campus. So in actually starting in 2015, we've changed the test because we can't put peer review on it anymore. We have condense it to a regular process-based integrated writing, and we put it online. Right? And very luckily, you saw the year, we did this right before COVID started. So when COVID happened, we had no transition at all. Everything maintained as usual. But in 2021, we realized that we need to actually do more, right? We need to not only have placement results, but we also need to have diagnostic information that can feed into the classroom. So we actually changed our rating scale a lot to make it a multi-tier assessment system. And then right now, just 2 years ago, we started to explore putting everything and making that to incorporate AI elements. So this is kind of a very simplified version of the development over the years. And when we developed the rating scale, I can quickly go over this, is that we want to make sure, if you remember the tension, we want to make sure the scale maintain a good balance between rhetorical structures and lexical grammatical features. So we've gone through a 3-year process to develop the rating scale along with the rater training system, just to make sure our scale aligns better with the curriculum and at the same time are better at capturing the nuances in the students' writing performances so that we can give them useful instructional information. So what we found very clearly is that by going through the best practice in scale development, that we saw there are different kinds of profiles that exist among students. That is, you might have students who are just strong in argumentation and grammar, but you also have students who are kind of in the middle of the category where they have different strengths and weaknesses. Some might be really strong in lexical grammar, but pretty weak in argumentation, or the opposite profile. So as sort of an outcome of the sort of emerging discussion that we had between the testers and the language teachers, we decided to develop a profile-based rating scale. This scale covers 4 levels of placement results, and in fact, only 3 of them are actually used. So you can use the placement result A, B, C, and D for classroom placement. But once you get into the class, their writing profile can actually give more instructional value to the teachers. So teachers can actually group students based on their relative strengths and weaknesses, right? So if you're actually on a 1 profile, that means you're relatively better at argumentation. If you're on a 2 profile, you're relatively better at lexical grammar. So there are altogether 4 levels and 6 writing profiles. And we've developed a full suite of assessment materials. These are our full rating scale that we share with our stakeholders so that we know what we actually need. So you can see it's a combination of argument development and lexical grammar features. I can share this later if you want to take a picture. And then we also develop a rating guide. That's because you saw there's so much information to take in at the same time. We need to somehow simplify it for our raters, right? So we break down that criterion into individual diagnostic questions. So now you can see by doing this, we have placement, we have profile, we also have individual diagnostic information that we can give to teachers. So given this, we've also validated the rating scale, and luckily actually worked out pretty nicely. So these are output that we generate from Roche analysis, which is a way to statistically generate what they call latent scores, or taking into account measurement errors. So here you will see these different colored lines represent different placement levels. So you get argumentation, lexical grammar. So you will see A, B, C, and D are clearly separated. And then when you look into profile, you start to see these crossing lines that really represent the different profile differences. So given this, we know, at least we've achieved something, that we've transformed a test that is mostly just used for placement into placement plus diagnosis. So this way we can align our test better with the instruction, and instructors can also get that information they need without having to do a diagnostic assessment. So now that was the very beginning. That was, I think, before COVID. After COVID, when AI becomes such a big buzzword, we thought about whether we want to do something with AI. And in addition to that, we did face some real problems. So these are our motivations. First is labor and cost. Because we're testing more and more students, it's actually quite taxing for graders to rate the essay and generate the scores. And also, our test administration tend to focus purely like in our summer session. So in May, this month alone, we test about 1,500 people. So that is massive. So we need to think of ways to reduce our human rating. Then with our teachers, there's the additional layer. We call it language assessment literacy challenge, is that teachers don't really think testing has anything to do with them. They don't want to rate, they don't want to assess. They think they're there just to teach. They don't want to handle anything related to assessment. And then, of course, we also want to build a team that focuses on language testing and computational linguistics. So there are all these motivations that we had together. So we started to jump into this journey of AI exploration. So we have, over the years, accumulated a lot of data that we can start to deploy. So we have altogether over 200 prompt sets that we created, and a total of, back then it's 8,000 essays, now we have 12,000 essays together. And among them, we've selected over 3,000 benchmark essays where graders agree with each other 100%. And these all they all have their metadata, right? Like placement level, performance profile, and we've got students' background as well. So to explore this, we thought about many different things. We wanted to explore AI's automated item development. We also want to explore automated score, right? Because those are the things where we spend most of our human labor. So to do that, the first thing is that we need to actually start to explore and extract features that we have from those essays, right? We need to actually really build our corpus. So we've actually started with a lot of features covering different domains, like lexical grammatical complexity, cohesion coherence, and we also develop our in-house fine-tuned large language model to automatically extract two-minute model. So we want to use argumentative structure to actually build our system, and that's also a novelty. And then we also have source essay semantic similarities, where because we're source-based writing, we also want to see ways that we use sources. So given all these features, you will see they are covering a lot of domains. And not just this, because our tests also have speech, because we have a listening passage, we can also analyze all the speech features. So all of these become our wealth if we want to develop AI solutions. All right, so to begin with, our first goal was to develop our AI system, right? Because we had a multi-tiered AI system. We can't be satisfied with just a regular automated assessment. We have to build a tiered AI system that can develop placement results, profile, and diagnostic information. So our model is more like this. This is our assessment system pipeline. So I'll quickly go through. So we first split our data into training data and test data, right? It's normal practice with machine learning. Then we feed into different kind of prediction models. And based on the training data, we actually make up predicted indices. Here I'm calling it indices, meaning like these are actually the intermediary number. So we don't just use the outcome right away, because we have to convert that into a label. Because in the end, we have placement results and profile. By having this intermediary layer, we're able to actually use prediction system to predict continuous variables. So give us more power, basically. So basically, you'll see three parts. One is the training model, to build a model that predicts. Then we test it on testing data. And then we also work out a separate algorithm to change from our original predicted outcome to the actual label that people can actually use. So given this, we have lots of things to predict. We have placement results, we have analytic profile, and we also have diagnostic information. Right now, our stage, our exploration have only gotten to this this one, my student and myself are still working on it, so I'll only present two parts of it. So to begin with, we've actually used a regression model to predict placement. This is the easiest. This is also sort of the most standard automated essay score. So you will see these three tiers, right? 2 semester, 1 semester exams. So based on all our features and training, we actually achieved a pretty good outcome. So you will see that the prediction accuracy, these are precision recall F1 score, right, which is a harmonious mean of these two numbers. So, but you will see they tend to align, right? What we see is that the prediction of these two levels, the ESL level, are pretty good. They're not very strong, but for local context, I think we could make it better. But the problem lies at the highest level, we actually have pretty low accuracy. For those of you who are interested in automated scoring or machine learning model, you will say oftentimes you need to have enough data at each level to build a better accuracy performance for your models. But our challenge was that very few people are actually exempt from our test. So it's very hard for humans to give the highest score in our system. That's our comparative problem. And we saw that being replicated in our AI system as well. But overall, it's okay. It's not too bad. But then we move on to profile prediction, right? This one is slightly different. Predicting profiles, we're not predicting a gradually increased scale because these profiles are all different. So we have to rely on a different kind of machine learning model. So here we use Gaussian mixture model, which is a clustering technique. Think of it as a k-means clustering. The only difference is that with Gaussian mixture model is actually better at accounting for the probability distribution of different kind of profile, but the interpretation is quite similar in the sense that you feed into the model a lot of features. Then it's going to give, the model will first identify how many clusters or groups you can actually extract. That can be linked to our profile. And then based on the profile, each essay will be given a soft probability, like what is the probability of getting into profile 1, profile 2, profile 3. And based on that, then you can actually decide which algorithm you use to lead to a final outcome. So in many ways, very much like cognitive diagnostic assessment. So with our features, what we first did was we first subject that to a principal component analysis to see what kind of data dimensions. We can't all feed into 54 features because that's very hard to interpret. So we first reduced it to 4 PCs, and they're quite interpretable. So the first dimension we had was lexical sophistication. Then the second is syntactic complexity. The third one, we call it argument structural complexity. It's actually all kinds of frequencies, all those tuning elements we extracted. And the last is source relevance. These are more of the semantic similarities between source and essays. So we get these 4 PCs, and they tend to explain a pretty good number of variants of the raw features. And once we did the classification, we saw that mostly, if you're familiar with the Gaussian mixture model, in this graph, it's basically showing you how well each profile is actually being predicted. You kind of want all of these sort of triangles to be on the right-hand side, right? That's more positive value, meaning that the model is capturing that differences. But if they're more negative, that means there are potential misclassifications. So it seems to be showing pretty well, and even though these might be a little bit overwhelming, but these are individual essays, cluster scores. So what we saw is, from all this, we could get 5 profiles. We didn't get 6 because we didn't have the lowest level we had. We had this, based on their cluster means, we had 5 profiles that are linked to our B1, C1, into C2A. So if you look at this, for example, B2, those are relatively stronger in lexical grammar but weaker in argumentation. Right? So we see that they have high scores on lexical sophistication, average score on syntactic complexity, and average on argument structure and source relevance. Right? Not 100% aligned, but it's kind of close to that kind of trend. Right? Or if you take another example here with C2, these are, I'm sorry, let's use C1 here. That's much of a contrast. But C1 are people who are slightly better at making the argument, right? But then really low on language or lexical grammar. So we can see from this profile, they're pretty low on these two dimensions related to lexical grammar and their average on invitation structure and source relevance. So based on this, we actually manually equated these different profiles to these 5 profiles on our scale. And then we can compare how accurate these predictions are. And as you can see here, the accuracy has dropped when we compare with predicting just 3 levels. But it's still pretty okay. But the problem remains. At the highest level, the accuracy dropped quite a bit because we have sparsity. So that's kind of where we are in terms of automated scoring. I wouldn't say this is perfect, but at least we've developed everything in-house from scratch. Right? Given our regular test administration, we can actually update our model every single year when new data is coming in. So we were able to, I guess, at least build architecture of our AS. Then our recent explorations are actually about automated item development. In the interest of time, I'll go real quickly. So our goal, and this is actually not our burning problem because automated scoring does. So with automated item generation, we also wanted to see if we can actually use AI, generative AI tools, to automatically develop prompt sets that are of comparable item difficulty or task difficulty. Because we need to ensure every prompt we give to test takers are somewhat comparable, right? So that it's more fair. So here to do this, not only we need to rely on all the knowledge about prompt engineering and all that, but we also need to actually tackle that with computational psychometrics, because we want to ensure we can create items that automatically align with like internal item difficulty. Right? So computational psychometrics actually is a new area in measurement as well, where what they do is they use all the NLP techniques or the computational linguistic techniques to represent items as features. In some way, it's like automated scoring. But when they feed all those features, they don't use it to predict score. They use it to predict item difficulty. So as they continue to train this iteratively, they are able to generate items that are specific, targeting specific linguistic features that link to a specific fixed task difficulty. Right? So if you can achieve this, you don't have to pilot your test that much. You can already tell the machine to say, well, I want this level of difficulty. Just create all the prompt sets like this. So that's what we're trying to do. And this is our pipeline. So what we first do is, maybe we're quite familiar with this, but we first have to tell AI, or ChatGPT, what we're trying to test. Right? And we need to create our test specifications. Then we have to prepare some training data, right? We have to give them our best prompt sets and tell them to create something similar. Then we tell them, these are item specifications, focus on each one of them. Then through an iterative process, we train the generative AI to create these items. Then we couple that with human review validation. This part we feed it into machine learning to create task difficulty. And through this process, we repeat it iteratively until we feel comfortable. Then we will actually launch the item and monitor them. Right? So that's the process. So you can see it's very similar with how we usually interact with ChatGPT, but this time we add a machine learning process to predict the material that they generate to the task difficulty that we get from real data. So what we did was, from our 200-something prompt sets, we also split our data into training and testing data. Then we go through a separate kinds of machine learning algorithm, because this time we're predicting task difficulty. It's a continuous variable. And in terms of model evaluation, we cannot just see prediction accuracy anymore. Because they're a continuous variable, we're using like R-square or root square error to see to what extent they can predict the variance of this task difficulty. Right? So the logic is pretty much the same, right? So we've explored all those features that we had, and then explored a couple of different machine learning algorithms. And what we found was, no matter which one that we use, the prediction seems to be pretty okay. Because testing R-square is telling us that our machine learning model can predict about 80% of the variance in the task difficulty. So it's actually pretty strong, given what we have. And what's really interesting is that when we look at all these domains and trying to see which features tend to predict the most, the results are surprisingly simple. Like with lexical complexity, it's really just about the frequency of trigrams in the source text. And it's the more easy or the more common these lexical bundles are, the more the easier the task tends to be. For syntactic complexity is the mean length of sentence in the source text. The longer text, the more difficult the task tends to be. And we also find interesting things as semantic similarities between source text and listening passages. So if you see more synergy between source, like listening passage and the reading passage, the task will become more difficult. This might be counterintuitive, but our task is actually asking people to give a stance between competing sources of information. So the more similar they are, the more difficult for test takers to identify the differences. And then pronunciation features, the more stressed words we have in the listening passage, the more challenge matters. Oftentimes, stressed words are associated with more information. Right? So all of these seem to make sense. It's just like they're a lot more simpler than I thought. It's nothing fancy. And fluency, we didn't find anything. Our texts are prescriptive. There's no disfluency in our speech at all. So given this, at least it seems to make sense. Our initial exploration seems to be working okay, right? And that's an area that we're continuing to explore as we go. But just based on these couple of AI explorations, we have some kind of initial reflection, right? None of our AI systems look fancy, right? If you compare with Duolingo, night and day. But I think it worked. And also by doing that, we're developing a tailor-made multi-layered AES system that allow us to align with local writing curriculum, provide diagnosis for teachers and students, and this can bring long-term benefits because with our system, we have reduced our reading load by half. And maybe we have more room to make it better as we go. And also the automated item development project, we need to see because we only have 20 or so prompts every year. So in terms of economic benefit, it's very little. It's just our team's own curiosity to see what we can do with this. But what I also want to say is that this doesn't come overnight. So this is how I planned everything. When I started in 2015, everything was paper with pencil. I used all my startup funding to hire RAs to digitize everything. So, and I carried that all the way through into 2019 to make sure we have data to begin with. And then also when we launched the online test, that gave us the additional boost. So we can continuously get more data in. And by doing so, as you can see already, this is not something that typical or traditional language testing experts can do. And we learned this the hard way. And by doing so, we actually established a collaborative code writing structure between me and my colleagues. So all my students are trained in language testing and computational linguistics. So through collaboration, we all learn at the same time. That allows us to continue this kind of collaboration. Because there's no funding, right? Like I said, how can you convince the computer science system to work for you when none of this is profitable? But luckily, we do have colleagues in the department who are interested in training students. So that's how we actually build that collaboration. And there's research coming out as well. And then we constantly need to seek funding, whether it's campus, state, national funding, or federal funding. We always do to make sure we have additional R&D funds to cover students' time. So these are all planned, but these yellow, orange stuff are reactive. I have to acknowledge all the generative AI explorations because of the training that we have. But we still think, by and large, our main assessment problem comes from the planned activities, because this is where it really solves the problem in our local context. All right, but then also I have to work a lot, right? I'm sorry for moving a little bit beyond research, but I think to make this happen, we have to think about sustainability. So oftentimes I realize by doing this, my work has shifted a lot to working with policy administrators to make sure our university provide consistent support. You also have to make sure all the test users are okay with you using machines for students' essays. So all of this is a very difficult negotiation process, but it needs to happen over time. And through this, not only you build collaborative relationship, but you also have built a community of practice with policy leaders in your context. So they always support your initiatives. So I think hopefully through this quick demonstration, we know that there's a lot that we can do in the local context, right? If you compare with AI in large scale, in classroom-based assessment, I think there's room for growth, tremendous room for growth in the local context. It's just you need to select and think about what's more suitable in your local context. And here I highlight a couple of things that I personally think that could be directions to both, right? These are things that we couldn't necessarily explore in our local context, but maybe in other contexts, it would be really great. Like nature of AI-assisted composing process. If you have a group of experts who really get involved in L2 writing, I think this is where you can definitely spend more time on to explore the construct, right? Idle generation, I think it's something that we can always explore, whether or not we choose to incorporate computational psychometrics. We can always do it for classroom-based context as well, right? Automated scoring and feedback, right? This, as I've demonstrated, has great potential. But in addition to that, I think we can also do more. This is what I personally think we should definitely do. In the local context, we can actually model more complex behavior in the testing process, like how do raters work, right? We know there's a lot of traditional analysis of rater performance, but you can also think about how you can actually use it together with machines, trying to see if the machines can actually predict human behavior. If they can, that really address the problem of human-machine comparability. Right now, a big problem for us is still can a machine actually do exactly what humans do. But if we can better understand how machines work compared with human, or try to use a machine to understand how human works, then I think you would be able to make a big leap in this area. And modeling task complexity and item difficulty, right? And then modeling the interactions among all of these facets, right? Not only looking at the test takers, task raters, how they interact with each other. Right? Once you do this, I think we'll be able to build a more comprehensive network of theories about AI-based writing systems. So, moving beyond writing assessment, I think there's also more you can do, right? For example, with computational linguists, you can explore the automation of underexplored writing constructs, like what we did with 2-minute model. I think there can be a lot more to explore. You can build all kinds of systems to automatically extract these features. Then you can also focus on the cognitive processes when you're actually writing, right? This you can couple it with psycholinguistic measures, and in psycholinguistics too, or neurolinguistics, they're also actively seeking collaboration, trying to see how machine can be used to model this process than our traditional statistical methods, right? So we're, sky is the limit. Then cheating detection. This is something we've thought about, but we've never done yet. But I think it's actually a very fruitful exploration, right? Like for a local context in particular, when you don't have the security system, you need to at least try to explore whether or not students are actually using AI. If they do use AI, what do the writing look like? I think this will be something that local tests will have more advantage over large-scale tests. So this requires collaboration, right, from these different expertise. So I think in closing, just a few minutes, hopefully I've demonstrated to you there's a lot of potential, right, for AI exploration that still allow you to do R&D, but at the same time focus on the uniqueness or the strength of local writing assessment. But in closing, I want to talk a little bit about AI's impact on research and dissemination. So I think in terms of research topic, hopefully what I just said will give you some source of inspiration about where to focus if you're looking for a research topic. But when you're actually doing research and dissemination now, I think there's also something you need to think about that AI has an impact on. I'll quickly go through this, knowing that probably this will be something to your interest, but if you are interested in asking more about this, feel free to do that during Q&A or later. So right now with AI, right, not only we see AI being used for research and development, but we're also seeing it's used in publishing as well. And we have a couple of editors sitting in the audience as well. And we know that it's an area that's fastly developing. There's a lot of gray area. Policies that we had 2-3 years ago have rapidly changed right now. So all our journals are actually thinking about what AI actually means. What are the things that we can reasonably take as acceptable use? What are some of the things that we should still guard against, right? This, I think I want to start by quoting code, which is the guidelines that we are commonly sharing across journals and publishers, is that there's still a couple of things that we still don't want to change. AI is not the same as automation. AI technology must be fair. There needs to be transparency, right? And we need to acknowledge their biases in the data sources when they're actually used to train AI systems. So these are, I think, probably common knowledge now. And we need to make sure there are a couple of details that we need to take care of. Now, down to our field, I know different journals and publishers have their own different policies as well, but generally there's a couple of consensus. First is that assistive tools are not the same as generative AI tools. There are two layers to this. One is that if you're using things like Grammarly, that's not an issue. But if you want to use generative AI to assist you with your writing process, you really need to think about what's the level of use that you have. And whatever AI you use, you need to make sure it's transparent because it's in publication, including even automated item generation that we talked about. So basically, any kind of AI used, whether you're using it for research purposes or for writing purposes, must be transparent against those. And authors need to acknowledge that there are a lot of issues with accuracy, integrity, and originality of materials being generated. Even with our AI exploration, we're using ChatGPT now. I don't know to what extent. I think it's still a question about copyright issues. Can we actually own those materials? Luckily, we're not making profit, so it's not an issue. So the legal stuff hasn't hit us yet. But that's a problem if you want to develop your own test in the future for commercial purposes. And I think in publishing, there are a couple of acceptable uses and a couple of unacceptable uses in gray areas. In my opinion, using it for editing idea generation is not an issue. And you can use it for simulation as well. If your study is trying to demonstrate the research methods that you want to get data, you don't have to do it through generative AI, but I think you can do it too. Right? If you know how to, let's say, use R to do simulation, you can do it right away. But using generative AI is okay. It's great. Unethical use will be very clear. Text generation. If you're using it to generate large chunks of text, that's clearly unacceptable across all journals. Data fabrication. That's all definitely the bottom line of AI use. That is very different from this. Simulation, you can generate fake data, but the main purpose is to demonstrate a method. But if you're actually having just an empirical study and you're using generative AI to generate data, that's a clear issue. And what's more, I think, I don't know to what extent this is public knowledge, is that more and more publishers now has their own separate ethics committee, meaning that if they catch AI use that editors didn't catch, even if the paper has been accepted, they can actually remove your paper after acceptance. So this, because AI is so important now, the quality control system is gone beyond the editor's control to some extent. And for career error, I think this is something that is up for debate. Like, for example, using AI to transcribe speech. I think a lot of the issues deal with data privacy issues. Can you actually feed your participants' interview to a generative AI, right? I think it's not about accuracy. I think AI tools actually do a really good job of transcribing speech. But to what extent you have consent from your participants to use AI tools, I think that you need to think about. And some journals start to actually ask you to disclose this process. Data coding and analysis, this is another area. I don't think any journal will actually ban the use of generative AI for data analysis or coding, but the issue lies in the accuracy and the reliability of coding itself. I've seen lots of scholars, they just use generative AI to code, let's say, thematic analysis, and then they just publish that. Oftentimes, if we see that, we tend to reject those journals, those articles right away, because there's no way to verify the accuracy of the coding. It's quite controversial, and research material generation as well, because we know these AI tools have biases. Let's say if you're using these AI tools to generate some essays for raters already, to what extent those essays represent real tested writing? It's not just an ethics problem, it's actually a validity issue, right? I think these are the things that our field hasn't really started to explore, but we need to think about these gray areas, right? These are the things that the journals won't explicitly ban, in my opinion, but it could create all sorts of issues. It might surface during the peer review process. It might become problematic later on if someone does a systematic review or meta-analysis comparing AI-assisted research versus just human conducted research. So lots of things that need to unfold, I think, as we continue to monitor. But given that, I think we need to really make sure we are being responsible and ethical we use AI tools to consider all of these ethical issues. All right, now in real conclusion, quickly, I think technology has definitely broadened and diversified our values, philosophies, and approaches in using the language test. It's quite enabling, there's no doubt to that. But during this process, as assessors or language assessors, we need to be more knowledgeable of technological development. We need to be more thoughtful of potential interests and priorities we might have in the users of the data, and be open to new paradigms or models of collaboration and practice. And at the same time, right, when we start to become more open, we will see more opportunities. For example, we can actually use technology to explore innovations in local writing assessment in ways large-scale tests can't do. We can also develop AI-based assessment literacy, right, and that can be very localized, knowing what technology can do and what to do when they fail. But the ultimate goal, in my opinion, is to use AI to maintain a technology-enhanced local assessment ecosystems where things thrive based on sustainable AI solutions, and we can also use them to create values for stakeholders, not just like publishing a paper. We want to make sure we build a culture that is sustainable. So I think, definitely, as I mentioned, AI-based writing assessment is not just about publishing new papers, because there's a lot of papers to write about, but I think our responsibility goes far beyond that. We need to think about what can we actually use AI to do to enhance education, right, to enhance assessment. So the sustainable writing assessment program can nurture creativity and innovation in that sense, as long as you know your context well, know where your problems are, and know where to locate resources and build your creative practice. So in the end, I don't think I can do any of this alone. These are all my students who've helped at different stages. Some of them have moved on to academia, some are to industry, some of them are still on the market, looking for jobs, and some are still trying to figure out a dissertation topic. But I think I want to thank and acknowledge their contribution to my choices. So thank you very much for listening.
Thank you very much, Xuyan, for this very inspiring talk based on his experience and real, practical building local tests over the 10 years and maintaining it and developed it and innovated it. These are really based on his hands-on experiences. I think that's very realistic, gives us lots of insights as to what are the particular detailed difficulties that you have to go through. Not only just writing papers, but also really you have to develop something and real people are taking it. You have to ensure its validity, reliability. Some of my students are in this room. Okay, we have talked about those concepts. So now I will open the floor to all of you. If you have any questions, please come. You're welcome to raise any questions. No question?
Thank you. Thank you, Yanxing. This is like very dense, comprehensive. I think when you did the literature search or looked at the existing practices out there, seeing that AI is being applied more in a large-scale testing than in a classroom-based test, not so much in the local test context. Some would probably immediately take it as, oh, this is a gap. Our students would jump in to say, well, this is a gap because not many people are doing it. It is, but it also reflects sort of the reality because it's difficult. It's probably the most difficult and challenging area to do AI applications in local testing practices because, like you highlighted, we don't have as much resources and expertise. We are constantly struggling with. I have all these ideas about how the AI could be applied to, say, sorry about that, ELC, our English Language Institute practices and assessments and placement, diagnostic use. But seriously, we don't have that type of team, right, to support us, and let alone the money. So I think you chose a path that is not often traveled, but at the same time, it's really probably the most challenging path to take. But it's really admirable to start with. So a couple of, probably these are just local minor questions for clarification purposes. When you were talking about ultimate item generation, and this is for writing assessment per se, right? Yes. So you look at how, in your context, because you use read, listen to write tasks, so apparently generating the input materials that is at the comparable level of difficulties for different forms of tasks, different administrations to just, present equitable or equivalent forms. So you looked into all these comparable features, and like you said, you identified things that is not so subtle, like very simple. Oh, yes. Just the frequency of trigrams in the source task, right? To be the most sort of powerful predictors of, or not predictors, but yeah, features. I was also wondering, now comparability could be done from different perspectives. One is from the input text, difficulty levels, complexities, right? But at the same time, it is also comparability in the performance. Have you had a chance to look into students' performance data, say, not just the test results, but also, it's, but I guess that's a next step, feeding into your future plans, looking into their composing processes, for example, right? Will that be equivalent really across different administrations? But this is just clarification. Maybe you already started on this.
Well, that's actually a great question. Honestly, no. What we did, so checking comparability across problems is something that we normally do, but following the traditional method. We've never done anything with AI on that. We have never built a system to see whether or not the cross prompts are comparable. But I think it's actually a very interesting question, because I have to say that with this, the reason we could predict that is because we could use Rush to generate class difficulty. That's what we use to predict. We could actually look into trying to think maybe some average placement, or because we could get score distribution for each prompt.
Right.
And we can use that to predict.
That's exactly what I was thinking about.
Yeah, that's a very good idea. Yeah.
But at the same time, maybe asking, if these forms are being administered to different students, then comparability will be still a bit of, maybe using the same batch of the students to some extent. Not like overall, ends. So that's one. The other thing that I've noticed is your principal component analysis, right? Looked into like 4 different dimensions: lexical sophistication, syntactic complexity, argument structure complexity, and source use. As 4, that's right. And then you link to the profiles, which, if you look at the C1, it's like really low lexical, grammatical aspects of the performance, and then average performance on argumentation source use. That would actually lead to a higher profiling?
Oh, no, sorry. C is lower than B. This is not C. So A is the highest, followed by B, then C.
Oh, okay.
Sorry,
I probably confused with the C.
Yeah, I know. It's actually clarify, because every time I present, I always get this question.
Okay.
No,
that explains. To follow up with your argument structure complexity, I noticed how all these indices actually is in relation to sophistication and complexity, which is beyond accuracy, right? So that I'm with you on that, and I think that's the direction, and that's what writing assessment should be looking into. But how do you look at argument structure complexity? Because the 2-domain structure comes with all these different, you have a claim, then you have all the different elements with rebuttals, and that's right, data and backing, and all these counter arguments and counter rebuttals. So is that like how many different elements are being identified?
So what we did is that we built, like I said, we built a large language model to actually, well, not build, it's pre-trained, but we fine-tuned, to automatically extract every single sentence in an essay.
And label them as
like
one element.
Yes. So then we look to convert into normalized frequency.
Okay.
So that's how we did it. And we did this because of the prior research that we did based on menu work, where we looked into structural complexity, where we found higher level of essays seem to be associated with more elements being packaged into one algorithm.
Yes.
So that's why, based on that, we thought we can convert into normalized frequency. So that's what we're dealing with now. What I ideally hope to have, and I don't know if this is the direction you want to suggest too, is we're actually missing the quality piece of it.
Say that again, sorry, which
Argumentation quality,
yes,
right? How relevant that is,
yes.
right? How logic that is.
That's right.
Right now, we don't have any solution to augment that, but I think it's the direction that we have. Because we do have, with our data set, because that research is based on a prior research project, for that we have about 600 essays that are labeled in terms of argument quality, but not the entire data set. So if you want to do that, then we really have to label all of them. So with all of this, with, for example, the 2 minutes elements, we had 20 RAs coding a whole semester. So generate annotations. So none of this is actually done overnight. So but it's in-house because we don't have to rely on anyone for this. But yeah, a lot of our position has a pretty lengthy annotation process to begin with.
Yeah, that's a sort of challenge we are facing. I mean, me and my students also working on that, but we won't have ourselves, right,
I have to confess, in our context, what's really nice is that undergrad students can choose to study with a professor and get research credit, but then they just join their project and work as an RA. So that's how we get them. So I have to meet with them every single week to kind of teach them something in addition to annotation work. But that's how we get more students involved. And also in our context, it's unique because we have a lot of computational linguistics undergrads.
Yes.
They're very into this. This is kind of like their training. Like you have to get into annotation.
We have an MA program, an MS program. That's how I was working with the MS students as well. But still, not much resources now. Anyways, thank you. Sorry for taking up so much time. Yeah, thank you.
Thank you very much. She was looking at me, so I'm supposed to ask her questions. Well, thank you very much. It's just a wonderful talk, a lot of takeaways. So I was thinking about, so even though I know the focus is on ELT, English language teaching, English language writing, so for secondary learners, so I was thinking about in the higher education context, we always talk about academic writing, kind of argumentative writing, and the purpose of writing to learn, right? So is there any gap between the topics that have been used for this training and the assessment purposes versus the kind of learning tasks that our students and graduate students are asked to do for writing academic essays to demonstrate their learning? So there are 2 issues, right? There's the language issue, and there's also the content and learning issue argumentation. And that's possibly related to the exempted group as well, because and I'm familiar with the first year reading writing program in the US. And I know those a lot of American students are not good at writing. So the judgment on their writing quality probably means a very more complex aspects. It's not just about the typical type of lexicogrammatical issues we're talking about. So if we are going to expand on the model to make judgment about their writing quality, where there might be a learning component, right? For those native speaking undergraduate students, what would be the challenge and the difference?
Oh,
thank you.
That's a huge topic. That's a huge topic. That's a very good question because I agree completely. Because this, actually, as Professor John was talking, it reminds me of a fairness problem. It's like with ITA speaking tests. Like if you're familiar with in the US, if you want to be a TA as a graduate student to get your entry, you have to be certified to be a TA. You have to take the speaking test. One challenge that we typically face is that to what extent we should make it more authentic. Because by making it more authentic, that means you need to let the student teach when you evaluate the speaking. But we never let domestic students go through this process. So in my opinion, having them or scoring on teaching for international students is a fairness problem because you don't do it with domestic students. This is a little bit of a digress, but I think what you just mentioned kind of made me think about that. It's like, to what extent should we actually focus too much on the rhetorical stuff? Because in some way, I think it's worth testing, right? Even with domestic students. But I think maybe that construct focusing only on second language writing assessment could be an issue. But I do agree with the importance of the construct, right? So going back to this question, I think there are gaps. From what I can understand in the computational literature, most of the writing tasks are very simple. You start to have more now, but a lot of the old literature is just independent tasks. Yeah. So I think, I think how can we actually link it to learning tasks for students actually who are doing disciplinary writing, going through the classroom? That's a big gap. I think it's worth looking into, for example, same students performing on different tasks. If you can build a corpus, it's possible. This was years ago, before COVID, we were actually collaborating with the University of Birmingham and Fudan University trying to build a sort of cross-institutional corpus. So what we wanted to do is to document all students writing from the very beginning of the freshman year until they graduate. That way we can build a corpus of their disciplinary writing, then compare tasks. Didn't happen because of COVID, so unfortunately. But I think that would be something useful if this can be done. Then you will get more data of disciplinary writing than just writing on assessment tasks, because there is a lot of literature already telling us writing or speaking in an assessment context is a bit different than what you do in real life. So I think that's possibly a direction to go.
Thank you. So yeah, I think that has strong relevance to the University of Macau's EMI University. So it's not. I mean, we talk about writing proficiency, but over and beyond the level of writing itself, there's a lot more about whether they could use English to learn. So I think in the US, probably in the UK, for example, professors might not be in the content area disciplinary writing. Right. So then they might not be particularly worried about lexical choices to some extent. They look at to what extent the essay could demonstrate you really have understood this stuff, right? So here too, I think. So yeah, but it's very interesting because one of my former colleagues at the University of Exeter in the UK, so Philip Durrance, you might not know him. So he has recently got a huge ESRC grant studying the difficulties of I think school, maybe university too, writing tasks. They analyze the writing tasks.
Oh.
So not just for secondary learners, but for all university, higher education, and school students. And I thought that was really important. So it's not just about the language per se. It's all about we use the language to do stuff, right? So
if they can make it public, that would be wonderful. Because I think
they just got the grant, as far as I know. So we'll
in a couple of years.
I will see.
I think that's very important because I've seen similar kind of exploration, even including my students, who were really interested in multimodal composition. So they were trying to collect, finding all sorts of ways to collect writing tasks that they have in the actual classroom, content classrooms. I think that's an area worth exploring, and also I think it's an area that will learn a lot from content language integrated learning. It definitely is an area that needs multiple expertise. I can think of, like you said, in most of the writing courses in American context, we don't really work with content experts a lot, but we can see clear problems. I don't know if that will answer your question at all. What we start to see is that for graduate student level writing, the ESL program is claiming it can help them learn to write and publish, but then the instructor themselves have never published anything. And they're not in the content expert. I think it's a common problem. I think we should acknowledge that. And oftentimes they will correct language that is not the same and is inconsistent with their disciplinary norm. I think this, in my ideal philosophy, this is an area that definitely requires collaboration between language experts and content experts. The challenge, though, at least in my local context, was content experts don't really want to work with language specialists. They probably don't have time. And language specialists do have, it's almost like a survival problem because they want to make sure they grasp they try to sort of subsume all the construct under writing, so it becomes their territory. So I think there's that kind of issue at play as well. It's a difficult problem, but I think, one of these days, I think it will surface. It will become an issue for assessment.
Actually, I do want to join the discussion. Well, with this problem, I recall I did a project for Duolingo, And I actually collected both students writing for the Domingo writing task, as well as students, first year undergraduate students, content writing essays. The project itself is quite simple. We created more elaborated writing tasks, integrated writing tasks, for Domingo, because Domingo's writing is very elementary. We created the middle level of task and trying to see whether by adding our integrated writing task, Domingo's test scores have a larger prediction of the students' content course essays. So we did collect a wide range of essays from undergraduate students and trying to do the prediction, etc. We collected over 200 students' writings on our task and connected their content level writing. So that's linked to Professor Zhang's question. That's real. The essays or assignments that submitted for their content course for assessment. So we played a little bit of that. But the complexity is we find those content essays are so different, so much varieties, okay? Huge varieties. Even if we fit Hillary's, what's her? Yeah, Hillary's general model, we still find it it's not, it cannot cover all the types we find from those students. There are so many different types. So that's also raised the question of how do you, because of giving of these innate differences between the different genres, right? It's very difficult, and you can't get for you to use uniform writing assessment schools to predict something with such a variety, even when you cannot get a high prediction or predicted variance, you cannot. It's probably because of within this outcome variable, there are so many variables already. So it's very difficult because you cannot get a big enough sample for each type of genre, outcome genre. That's something. But I do think with Yanxin's project, I do come back to think about perhaps I can work further on that set of data. We actually annotated it. We got quality raters to rate it. We can actually explore further, perhaps utilizing some of the computational, psychometrics, to play with those texts. So there's certainly some possibility to go beyond. But another thing I was thinking about is, Yanxin's talk is about a local test that he's actually responsible for. Although there's lots of challenges in these types of locally based tests, but I also think there are lots of opportunities there. As I see it, he actually can build upon it, and developing something that is useful, applicable, meaningful for his context. Well, on a lot of times, when we are far from this kind of testing and practice context, we are looking for research topical or focuses from literature, which is which is okay, but not so exciting, right? So I think the insight that I get from this is perhaps sometimes looking at where you worked, right? Your own context, and thinking about the real problem you can address, or you can address for people you care about, your students, your teachers, your school, right? I think that can really generate that kind of excitement and, a sustainability. You can work continuously for that. Even if you cannot publish from it, you still have done something meaningful, right? So I do think, the locally based test is an opportunity in that sense. And it is sad we don't have that kind of test in here. Do we have? Joshua, do we have that in your?
Yes, ELCU placement test, but we don't get paid. It's part of our job.
Oh, yeah, you don't have that.
There's a joint admission exam by other universities that we work together that we're required to.
Oh, that's a joint university admission
Yeah,
test.
that's another, that's different from the US has their own placement test, but we have to all come together to.
Another one,
That's
okay.
part of our.
So you also have that.
We're not
Perhaps
big on
Joshua
that.
can work on that data. You have access to that.
That's,
Years ago, we developed one, right?
Yeah. Yeah, I find that quite interesting, right? So relevant to practice.
I think what I find, like with all the explorations, the key is definitely your data. Like if you build an instructor that gradually accumulate data, so like by the time when we first started with Hubble, when it's going to be and we can have enough. But as we were starting to work on the project, and the data just keep coming in because you're accumulating every year. So the key is to build infrastructure.
Yeah. It's exciting, right? It's exciting. Yeah, it's lots of opportunity. So I would like to invite any other questions from the floor. Students, we got lots of students here. We even got some school teachers. Do you have anything to say? I do see that there's lots of opportunities in your classroom test, in your school's test. If you apply, those AI tools, or to play with the data and to make your assessment task better. Like if you are having a language classroom test, okay, language test for schools, semester-based test. Anyway, we are actually running out of time, so last call. Any questions? No question? Then let's thank Yanxu for this wonderful talk.